1, 2. Good evening. This is VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Harry Warren South. Good grief. We're broadcasting on prime frequency of 3541 kilohertz in the 80 meter amateur radio band, and way too much audio, and just making sure my levels are right. Where am I here? 1, 2, 3, 4, 5. Way too much. Why is that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, okay, I think that's okay. VK3EKH on 3541 kilohertz, and also via the Melbourne television repeater, VK3RTV, digital channel 1, and streaming on my HD Discord channel, and also on the YouTube stream. Just look for the live indicator for VK3CSJ. Alrighty then, once again it's just a last minute rush to get things prepared for tonight, and then finally doing the quick audio tests and adjustments, and I think we're doing okay. 1, 2, 3, 4, 5. It's strange my levels on vMix seem to be a little bit obscure. I'm not sure what the reason is for that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. VK3CSJ testing on the microphone here on behalf of VK3EKH. Alright. Oh dear. Yeah, I've got my levels aren't right on vMix. The left channel is higher than the right channel, and everything looks okay for that, but I don't know why it's doing that. Anyway, alright. I'm going to give this game away. I think this is too much hassle for a Friday night for me. I'm just about over it. Oh. Alright. Where am I? On this 24th of October, and we've got another solar report from Tamitha Scove tonight. Not as long as last week's, but still she's reporting on a couple of interesting things that have occurred on the sun in the last few days. But apart from all that, the Astronomical Society of Victoria was founded in 1922 and comprises over 1,800 members throughout Victoria and Australia and overseas. Membership of the Society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, except in January, the latter being held on a Saturday night. Meetings start at 8 p.m. Mulia Hall, Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Meetings are also live streamed for those who cannot attend. Parking is available in Burwood Avenue, Dallas Brooks Drive and the surrounding streets. Admission is free and visitors are most welcome. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory. Receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical yearbook, which is published by the ASV. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's a 200mm refractor managed by the Royal Botanic Gardens and a fully restored photoheliograph are also housed at the observatory and are accessible as well. The Society also has a number of 200mm reflectors available for short period loan through the ASV's telephone loan scheme. A member can gain practical experience in the use of one of these telescopes before deciding whether or not to buy one of their own. Regular society meetings are held at the Morley Community Village in Bentley East. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90-minute drive north of Melbourne. It provides dark skies suitable for astrophotography. There is a range of instruments available for members to use, the larger two only with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5-metre Kennedy dish radio telescope, which members can access with involvement with the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the several common interest activities catered for within the Society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral meteor, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors can be found on the ASV website at www.asv.org.au. Further information may be obtained by visiting the ASV website, and notifications of events are given in the Crux Extra bulletins sent out via email to members every other week. Please note that the ASV will conform to any government health directive, and thus ASV events may be required to be cancelled, removed or postponed. If you wish to write a letter, a physical letter to the ASV, the address that you would put on your envelope is the Secretary, Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001, and yes, and again the ASV website is www.asv.org. It's org.au, and that's it. All right, we'll see you all next Friday. Bye for now. All right, now let me see. We do have a email address as well for those wishing to send signal reports. It is vk3ekh@gmail.com. vk3ekh@gmail.com. And I can see that John is listening there. G'day, John. Always listening on the YouTuber. All right. Where am I now? Been binge watching a program on Stan streaming service. If you haven't ever seen, what's it called? Breaking Bad, I recommend it. It grabs you in. Not really sure when it was made. I think it was a couple of years ago, but it's called Breaking Bad, and I've been well and truly enjoying it. So it goes for 5 seasons. Every episode's about 48 minutes, so it's a recommendation from me to see that. If you haven't seen it, see it. It's on Stan. That's if you got Stan. Alrighty then. Where am I here? Oh yes, I've got to look before I go into Timothy's report. There's just a few quick articles I'm going to zip on through. Because I'd really like to get over and done with. Courtesy of Astronomical.com, there's an article published on the 21st of October. I'll bring up the picture. It's a mad rush to get all these images into vMix. I'm just over it, you know that? I'm over it. Alright, there it is. You might recognise that. That's the observatory in the backyard. It's called the Yerkes Observatory. That is Yerkes. Yerkes, I guess that's how you pronounce that. Why does it sound like I've got no bass? My bass seems to have disappeared here. Maybe I've got too much tone on or something. I'm just mucking around with the EQ here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. That sounds better. Yeah, more bass in that. Okay, it still sounds a bit high end. 1, 2, 3, 4, 5. Anyway, right. Oops, just knocked the microphone. In 1892, George Ellery Hale, a professor of astrophysics at the University of Chicago, convinced the university president to acquire 2 40-inch telescope lens blanks. With funding from Charles Yerkes, a Chicago mass transit tycoon looking to refurbish his image, Hale spearheaded the creation of an observatory to house a great refractor made with these blanks, blanks. Part of the terms of Yerkes' financial backing was that the observatory be built within 100 miles or 161 kilometers of Chicago. So a location in Williams Bay, Wisconsin, 145 kilometers north of Chicago, was selected and construction began in 1895. Park-like grounds were designed by the famous Olmsted brothers, and the building itself is a ornately Romanesque, a 40-foot diameter dome houses the famous 40-inch great refractor, which remains the largest refracting telescope in the world. On October the 21st, 1897, the observatory was formally dedicated. Over the next century. Work done at Yerkes led to its recognition as the birthplace of astrophysics and a home for great astronomers, including Edwin Hubble, Edward Barnard, Gerard Kuiper, and Carl Sagan, and Nancy Grace Roman. Although the University of Chicago's attempts to sell the observatory in the first part of the 20th century led to a long period of uncertainty, the Yerkes Future Foundation took ownership of the facility in 2020 with a focus on restoration, public outreach and education. and of course the preservation of the historic site. So that lovely telescope dome, 40-foot, is it what it was? 40-foot dome. What did it say that? The size of that dome? 90 foot, sorry. A 90-foot diameter dome, which houses the famous 40-inch Great Refractor Telescope. That'd be something to see. I should see if I can find the picture of the telescope itself. But anyway, yep, lovely look to look at that. These magnificent buildings that are associated with it. Excellent stuff. You're tuned to ASV Radio, VK3EKH, coming to you from the studios of VK3CSJ, Narre in the south. Next article, courtesy of astronomy.com. Can Mars ice confirm past life? Can Mars ice confirm past life? Researchers have learned that microbes last a lot longer in pure water than in soil, it seems. And there is a picture associated with this article, so I'll throw that up as well. Okay, so this article, quickly, where are we? What you're looking at there is this mosaic is made of 32 orbital images captured between 2004 and 2010 by the high-resolution stereo camera that was part of ESA, Mars Express spacecraft. It shows the North Polar ice cap of Mars, a location researchers think may contain evidence of past life on the red planet. The article continues to say that in a recent study, a team of researchers from NASA Goddard Space Flight Center in Penn State suggested that future missions to Mars search for microbes or their remains in the planet's ice rather than in its rocks, clay and soil. In a lab, the team recreated conditions that exist in the permafrost and ice caps on the red planet. It showed that some amino acids that make up proteins in the Escherichia coli microorganisms could remain intact for more than 50 million years, despite continuous exposure to cosmic radiation. 50 million years is far greater than the expected age of some current surface ice deposits on Mars, which are often less than 2 million years old, meaning any organic life present within the ice would be preserved, said co-author Christopher House, professor of geosciences affiliated of the Huck Institutes of Life Science and Earth and Environmental Systems Institute. That was Huck, H-U-C-K, just in case you thought I said something else. And director of the Penn State Consortium for Planetary and Exoplanetary Science and Technology. Good grief, you can imagine that a singular door to your office with all that written on it. Anyway, that means if there are bacteria near the surface of Mars, future missions can find it. So, what is the experiment then? The research team was led by Alexander Palov, a space scientist at NASA's Goddard. Members introduced some of the E. coli bacteria into test tubes containing pure water. Other E. coli samples were mixed with water and ingredients found in Mars rocks and clay. They then used a gamma radiation chamber cooled to minus 60 degrees Fahrenheit to expose the samples to the equivalent to 20 million years of cosmic ray exposure on the Martian surface. Researchers later added the equivalent of an additional 30 million years of radiation for a total 50 million year time span. In the test tubes containing pure water ice, more than 10% of the amino acids from the E. coli sample survived. The samples containing Mars-like sediment degraded 10 times faster and did not survive. Based on a previous study, it was thought that organic material in ice or water alone would be destroyed even more rapidly than the 10% water mixture, Pavlov said. So, it was surprising to find that the organic materials placed in water ice alone are destroyed at a much slower rate than the samples containing water and soil. So what is the reason for all this then? The team proposed that the faster destruction of amino acids might be due to a slippery film that forms where ice touches minerals. That allows radiation to reach the amino acids and destroy them. While in solid ice, harmful particles created by radiation get frozen in place and may not be able to reach organic compounds, Pavlov said. These results suggest that pure ice or ice-dominated regions are an ideal place to look for recent biological material on Mars. NASA's Phoenix mission, which touched down on the red planet in 2008, was the first to excavate down and capture photos of ice in the Mars equivalent to the Arctic Circle. There is a lot of ice on Mars, and most of it is just below the surface, House said. Future missions need a large enough drill or a powerful scoop to access it, similar to the design of the capabilities of Phoenix. So yes, I hope that in my lifetime we do get to Mars and be able to do some of those interesting things that they talk about. I hope so anyway. You're tuned to ACE Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, broadcasting since 1988. Not necessarily every week, but we try to. Good evening to Russell Ward if you're listening there. Mumble. ScienceAlert.com. There's a lot of talk at the moment about various asteroids and comets flying around the solar system. Here's one. Hidden near-Earth asteroid discovered lurking in the sun's glare. An artist's impression of an asteroid hiding in the sun's glare. Let me bring up that picture. Where is it? There it is. You can all stare at that for a moment. Courtesy of ScienceAlert.com, published 22nd of October. In the distant past, the solar system was rife with impacts and collisions. Millions of rocky objects zoomed chaotically through the system, smashing into each other in collisional cascades. Over time, many of them eventually became part of the rocky planets. What's left of the space rocks are mostly gathered in the main asteroid belt, which exists between Mars and Mars and Jupiter. But some are otherwise hidden in difficult to observe locations. Unfortunately for life on Earth, some of the most difficult to spot ones are close to us. They're hidden in the sun's glare and are uncomfortably close to our earthly home. A scientist at the Carnegie Institute of Science, or for Science, has discovered a new asteroid in our neighbourhood, and its name is 2025 SC79. 2025 SC79. And it's the newest member of the Atira asteroid group. Atira asteroid group. These are near-Earth asteroids with orbits entirely within Earth's orbit. Atiras are the least numerous group of near-Earth objects, and 2025 SC79 is the 39th member. So there's so far 39 that we are aware of. Here is another image. Bring that up. And Atira asteroids follow orbits entirely within Earth's orbit, and that's giving you a bit of an idea. These objects are challenging to spot because their meager light is drowned out by the sun's overpowering glare. This new space rock is only the second known object with an orbit entirely within Venus's orbit. It also crosses Mercury's orbit and completes a trip around the Sun in only 128 days. It has the third shortest orbital period of any asteroid, with two fastest ones both having an orbital period of only 115 days. For comparison, Mercury's orbital period is only 88 days. Carnegie science astronomer Scott S. Shepard discovered the asteroid on September 27 with the Dark Energy Camera on the National Science Foundation's Blanco 4-meter telescope. That telescope searches for killer asteroids, and 2025 SC79 certainly qualifies. 2025 SC79 is about 700 metres or 2,300 feet in diameter. While small compared to the Chicxulub impactor that ended the dinosaurs, that size asteroid would still create catastrophic impact on continental scale. Depending on where it landed, it could kill billions of people and animals. The sighting was later confirmed with two other telescopes, the NSF's Gemini telescope and the Carnegie Science Magellan telescopes. And here's another image which is meant to indicate that they found something moving about the universe, the solar system. Where's the article again? So in these pair of images that you're seeing on the screen right now, this pair of images shows the near-Earth asteroid 2025 SC79 moving through space. It has the third shortest orbital period of all asteroids, taking only 128 days to complete in an orbit. The most dangerous asteroids are the most difficult to detect, Shepard explained in a press release. Most asteroids research finds these objects in the dark of night, where they are easiest to spot. But asteroids that lurk near the Sun can only be observed during twilight, when the Sun is just about to rise or set. If these twilight asteroids approach Earth, they could pose serious impact hazard. There's a lot to learn, or a lot more to learn about 2025's SC79, but that will have to wait. It's disappearing behind the Sun for a few months. Once it reappears, astronomers will examine it for more detailed information. Its composition is an important question, since its surviving exposure to the Sun's intense heat. Further observations may also shed light on the asteroid's origins. It may have been dislodged from the main asteroid belt somehow and then captured by the Sun. Many of the solar system's asteroids inhabit one or two belts of space rocks, but the perturbations can send objects careering into closer orbits where they can be more challenging to spot, Shepard concluded. Understanding how they arrived at these locations can help us protect our planet and also help us learn more about the solar system's history. Interesting stuff, that one. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Where's my camera gone? There we go. I haven't got any lights on in this room either. It's just the fluoros running above me at the moment. Alright, let's do a quick glance at the email. We have Andrew listening. G'day Andrew, VK3KIS. What are you saying? I can't find the Discord ATV. Oh my goodness me, you might be right too. Let me just check. I am. Yes, all right. I know why. Oh, my deepest apologies for that. I know why, because I haven't got the program running. Let me just do that. I do have video running from from vMix, and I have got the link to the Discord, but my apologies, I haven't got Discord running. Let me just get that started. Well, wouldn't it bother you? Come on, hurry up. Come on, hurry up. Are you going to start? Are you going to start? Or what? Oh, there you are. All right. Chat room, live broadcast. Turn on the camera, and there I am. And let me put some light onto the subject. All right, that's a little bit. That's not good enough, is it? Hang on a sec. Let me just go over here where my other light is. Oh God, that's dangerous doing that. Oh, that's a bit groovy. Yeah, alright. Alright, we are live on Discord with less than a second delay between what you're hearing on here to what you're seeing on video. Alright, so g'day Andrea, thanks for letting me know that. I should have picked that up much earlier in the piece, but really, I'm just over it. Alright, back to vMix. Right, next article. What time is it? It is approximately 29 minutes to 11, coming up to 28 minutes to 11. We're moving along pretty well here. Come on, stop coming up. Just trying to find my web. That's what I'm doing. Okay. Faint glow. There is a faint glow in the universe. Let me bring up that picture. Stop bringing up the mail. Good grief, I keep on clicking on the mail. vMix. Where's this image? There it is. Alright, what are we looking at? Oh, stop bringing up the mail. Finally. Courtesy of space.com. A faint glow in the Milky Way could be dark matter footprint. A dark matter footprint. This was published only 14 hours ago. That's what I like about the sites that I visit. It's possible we still see the new data and confirm one theory over the other, or maybe we'll find nothing, in which case it'll be an even greater mystery to resolve. In this picture that's on the screen right now, this is a panorama of 300 light years in width. So that image you're looking at there is 300 light years in width. It is a picture of the core of our Milky Way galaxy. Could dark matter signatures be somewhere in there, they're asking. The century-old mystery of dark matter, the invisible glue thought to hold galaxies together, just got a modern clue. Scientists say they may be one step closer to confirming the existence of this elusive material thanks to a new simulation suggesting that a faint glow at the center of the Milky Way could be dark matter's long-sought signature. It's very hard to actually prove, but it does seem likely. Struth, this is a funny name. Moritz Moreau of Lebanese Institute of Astrophysics, Potsdam in Germany. So his name is Moritz Moreau, Moorits. I think I got that right, Moritz. Moritz Moreau, Muru, of the Lebanese Institute of Astrophysics, Potsdam in Germany, who led the new study, told Space.com.
Dark matter, which makes up about 27% of the matter in the universe, remains one of the biggest riddles in cosmology. It doesn't absorb or reflect light, making it completely invisible to telescopes. Despite decades of experiments, from underground particle detectors to orbiting space observatories, scientists have never detected it directly. Now, however, new computer simulations from Mural's team may have brought us a step closer to decoding the mystery. The findings show that dark matter near the Milky Way centre might not form a perfect sphere as scientists long thought. Instead, it appears flattened, almost egg-shaped, and that shape closely mirrors the pattern of mysterious gamma rays observed by NASA's Fermi Gamma Ray Space Telescope. This builds on research dating back to 2008, when Fermi first spotted a broad, hazy glow of high-energy light near the galactic core, stretching across some 7,000 light-years. The signal was far brighter than existing models could explain. Some scientists proposed that these rays could be a byproduct of invisible dark matter particles known as WIMPs, W-I-M-P, which is short for weakly interacting massive particles, colliding and annihilating one another. Others argued they came from fast-spinning stellar remnants known as millisecond pulsars, ancient rapidly spinning neutron stars that emit beams of radiation like cosmic lighthouses. The pulsar theory made sense because the gamma ray glow appeared flattened and bulging, much like the Milky Way's star-filled central region. If dark matter were behind the glow, scientists had expected a smoother, rounder pattern. Mural and his team decided to put both ideas to the test. Using powerful supercomputers, they recreated how the Milky Way formed, including billions of years of violent collisions and mergers with smaller galaxies. Those violent events that researchers found left deep fingerprints on the way dark matter is distributed in the galactic core. When this complex history is factored in, the simulated dark matter halo no longer looks spherical. Instead, it takes on a flattened egg-like form, matching the pattern of gamma-ray emission Fermi has observed, the new study reports. We're showing that dark matter also has a flattened shape, Mura said, so it does match the gamma-ray excess much better than expected before, he says. The finding suggests that dark matter could still be a stronger contender behind the Milky Way's mysterious glow, but it doesn't completely rule out pulsars, the research say. Both possibilities, the team concludes, are now essentially indistinguishable. If the excess truly arises from dark matter collisions, it could make the first indirect evidence that WIMPs, a leading dark matter candidate, really exist. Definite answers could come by the late 2020s, when the Astronomical Telescope Array Observatory, CTAO, begins scanning the skies from its twin sites in Chile and Spain. The facility will be able to observe gamma rays at much higher resolution than Fermi, researchers say, potentially helping them distinguish between a swarm of pulsars, which have higher energies and lower energy annihilating dark matter particles. Murrell added that gamma-ray observations of smaller dark galaxies orbiting the Milky Way, smaller dwarf galaxies orbiting the Milky Way, whose cores also host dark matter in dense pockets, could further test both possibilities. That's where we hope to measure the signal, said Murrell. We're really looking forward to these observations. Scientists are convinced dark matter is out there. The quest to detect it arguably remains both one of the most frustrating and exhilarating challenges in modern physics. For some reason, it still eludes us, Murrell said. and I think the mystery makes it even more interesting. The results were detailed in a paper published October 16 in the journal Physical Review Letters. Courtesy of space.com, titled "A Faint Glow in the Milky Way Could Be a Dark Matter Footprint," published 14 hours ago, probably 15 hours ago now. Alrighty then. Let's see, what time is it now? It's 22.
What else have I got here? Mount Burnett. Plugging Mount Burnett Observatory. I think I've got a slide for that. A slide. Do I have a slide for Mount Burnett here somewhere? Yes, there it is. Just disappeared off the screen all of a sudden, and it did. It just disappeared. Alright, I won't worry about it. I've just lost that slide. What was I going to say? Anyway, Mount Burnett Observatory, making the wonders of astronomy accessible for all young observers every month. Radio astronomy and planetary science every month. Mount Burnett calendar 2025. Minimal calendars remaining. Oh, there's a calendar. They're selling a calendar. Mount Burnett presents our next public event is a special Halloween public viewing night on the 31st of October. So that's still to come. And tonight there's a meeting up there. They generally meet every Friday night up there. 24th of October, members night at the observatory. So that's happening up there. Yeah. Alright. Okay, I'll finish off with this little article before going into Tamitha. So, I think some of you folks will recognise this image when I put it up. Courtesy of the ABC News, this article. The dish still helping unravel secrets of the cosmos 25 years after film's release. So it's 25 years since the movie The Dish was released. And if you haven't seen the movie, I highly recommend that. I really would suggest you watch that first before watching Breaking Bad. Anyway, all right. And this is published 15 hours ago. Let's see what they say here. There's a few pictures associated with this thing. It is the movie that opened the eyes of the new generation to Australia's role in the first moon landing and turned a rural observatory into a tourism hotspot. The Dish was released 25 years ago and became an instant hit. It highlighted how the park's observatory in central west New South Wales helped beam the 1969 Apollo 11 landing to 600 million people around the world. The comedy film featured three-time Golden Globe winning actor Sam Neill as the lead scientist and used some creative license to detail how a group of Australian researchers was the globe's only hope of obtaining images of man's first steps on the moon. To conduct such a world-shattering event to somehow extremely ordinary like rural New South Wales, people loved it, Neil said. It is something that Australia can be proud of, and it is certainly something that NASA is always grateful for. And here is a picture of our wonderful dish. Been there and been there. The article continues on to say that Roy Billing, who played Mayor Bob McIntyre in the film, said that he was proud of how the movie helped put parks on the map. Even now, people come up to me and say how much they loved the film, he said. It was just an absolute joy to work on. It was a role any actor would die for. Reintroducing the moon landing. The movie was the brainchild of Rob Stitch, Jane Kennedy, Tom Glessner and Santo Killaroo from Working Dog Productions. Rob Stitch, said he had never heard of Australia's involvement in the NASA program until Glessner brought it up while discussing movie ideas. Rob Stitch, this is the director.
he reckons that he said he had never heard of Australia's involvement in the NASA program. Uh, well, maybe. All right, I'll go with that. We thought he was joking and didn't believe him until we researched some old newspapers, Stitch said. It's incredible that we did not meet a single person in the lead up to making it who knew about this history. And here is another picture of one of the scientists at the observatory who I've met. CSIRO's Parkes Radio Observatory Operations Scientist John Sarkisian was called in to assist in the filmmaker as an advisor. During the Apollo 11 mission, Australians were very well aware of the observatory's role. It was publicised everywhere, he said. In the intervening 30 years, people forgot about that, so the film was able to reintroduce the CSIRO's role to a new generation of Australians. We were able to use that to show Australia and the world just what it is that we do here. We are one of the leading radio observatories in the world. And here is an old black and white picture of the internals. Thanks, John. And the article continues on to say that scientists from the Parkes Observatory assisting with the moon landing in 1969. That's an image there. Tourism interest. Before the movie's release, about 50,000 people would visit the telescope named Muriang each year. That jumped to 138,000 in the years following and has since stabilised at about 100,000. One of the effects of the film was to make Parkes more of a tourist destination, simply to see the dish itself, Neil said. It is the true hero of the film after all. And here is another famous picture from the film. I think we all recognise what's going on there. This is one of the most famous scenes from the dish. Saw the scientists playing cricket on the telescope. One of the most renowned scenes from the film involved the scientists playing cricket on the dish. The most common question we get answered now at the observatory by visitors is, "Did you really play cricket on the dish?" Mr. Sarkisian said. And the answer, of course, is no. The reason they did film this was to give the dish some scale. They thought that they thought up this brilliant idea to make them do something that Aussies would, and that is play cricket. And here is now another picture of the real mayor of Parkes. I think this is who he is. At the time, I think. Let's read on the article. Ken Keith was the Parkes Shire Council Deputy Mayor when the movie was in cinemas. Okay, this is later. The feeling was electric around the town that the radio telescope was finally being recognised, Mr. Keith said. It was a wonderful movie for the Parkes community. It still brings a tear to my eye every time I watch it. I understand that. Ongoing work. Since the dish was first opened in 1961, its aim has been to conduct astronomy research. And here is a beautiful picture of the dish taken at night time. This is a really lovely picture. The Parkes Observatory conducts astronomy research and assists with lunar tracking. Muriang, I think this is an Aboriginal name. Muriang is one of the largest telescopes in the southern hemisphere, making it ideally suited to finding pulsars, rapidly spinning neutron stars that help our understanding of the extreme physics of matter. This telescope has been responsible for finding more pulsars than all other radio telescopes in the world combined, Mr. Sarkisian said. That allows us to study matter in extreme states that we can't reproduce here on Earth, he said. In 2024, the Parkes Observatory continued its legacy of lunar mission tracking, assisting NASA and SpaceX with the Intuitive Machines robotic spacecraft moon landing. It is only a small part of what we do. The space tracking, but they are invariably the most famous things, Mr. Sarkisian said. That is all the public ever hears. So they think that it is all we do, but we do far, far more, he said. And that's the end of that article. Anyway, it's a beautiful antenna. I can say that I've been there several times. I've toured top to bottom and flown around it in a helicopter, and the fact that I've had a chance to meet some of the scientists there was a bit of a buzz. So yeah, it's a magnificent installation. All right, let's go across to Tamitha. Bring up her caption, and let's queue up Tamitha. This goes for 8 minutes, so we should just finish nicely here. All right, I can see that my level on YouTube has dropped a bit of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Sorry about that. If the level seems to be low on the vMix side of it, I don't know why that is either. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, I just brought up the level a little bit there on vMix, but it's still a bit too low. Anyway, let's get across to Tamitha, and hopefully this will work nicely. Stand by.
We have a bit of a far-side blast, a small radiation storm, and multiple solar storms are headed on their way to Earth, which is going to give us a bumpy ride. Those stories and more are in this week's Spotlight. Space weather this week is picking up in a big way. As we take a look at our Earth-facing disk, we are saying goodbye to this coronal hole. This gave us some fast solar wind over this past week and gave us some beautiful aurora clear down to mid-latitudes, along with some other solar storms. And meanwhile, though, although things are calming down, we still are getting a bit of a bumpy ride. The first bit of it is this poof right here. Look at that, woof. That actually was a partially Earth-directed solar storm. It's going to go to the east of Earth mainly, but it's likely going to graze us here over the next couple days, and that starts our bumpy ride. But there are other filament eruptions that we're going to be talking about, mainly sympathetic eruptions that have been occurring because we've been having some massive far-side blasts. Of course, old region 4246 and 4248. These regions that gave us a lot of the activity on the front side of the disk just this past week, they have picked it up a notch and are really getting exciting. That may not look too much, but whoosh, look at that. So these regions continue to fire off big solar storms, and it's causing some sympathetic eruptions. We're getting a few filaments that are launching in several places over the past couple days. They may give us a little bit of solar storming. It's not really clear how big of a solar storm they're going to cause. You can see some of these poofs as they lift off. And it's part of that may also be because this is kind of a partial closing coronal hole that used to be right here. It's still got a few open field lines in this area, and so it continues to be a little bit more unstable, and it makes solar storm launches a little bit more likely. So we might see a few more filaments launch in this arena in here. But meanwhile, as we get back to the red disk, you can see some major strong filaments all in here getting very, very twisted up. This is a very unstable configuration. And sure enough, late on the 21st into the 22nd, we get a massive far-side blast. You can watch it coincident with a filament launch right in here. Whoosh, right there. We also get a lighting up of this region in here and a small launch from a filament, but you would not be able to tell because on the far side of the sun, there's region 4246 launches this massive far side halo, also starts a radiation storm that is still hitting Earth right now and is likely going to keep us at the enhanced level for the next couple days before things finally calm down. And believe it or not, in here somewhere, which we can't really see, is an Earth-directed solar storm. And I'll show you that as we move into looking at stereo data. We can tell that we actually do have an Earth-directed storm, but again, it's likely not going to be all that strong. So we're hoping that it's just going to give us a bit of a bumpy ride. Now let's switch to our stereo imagery. As you can see, here we got stereo looking at the sun from the far side, just to the west limb of Earth. And you can see regions 4246 or 46 and region 4248 really getting busy in there. You see, that's when it launched that big one. You'll watch it right here launch a really big solar storm. Let's wait for it. Wait for it. Come on, boom, right there. You can see the big post-eruptive arcades right here. This thing launched way off to the far side, so it's not Earth-directed, but it also launched that big radiation storm. In the same time, if we come back over here, these are the regions that are pointing mainly at Earth. And you can see, let me back it up just a smidge. You can actually, do you see how you get this little evacuation here? See how bright it is? Watch how it releases, whoosh, just like that. Do you see that? You can even see this part of the field line kind of bend down a little bit. So this is definitely a letting go from something that's going to be Earth-directed, but we just can't see it on coronagraphs. You can even see the closed loops forming afterwards because this big monster just took everything. So this is camouflaged inside those coronagraphs, and sadly we don't have good stereo imagery yet to be able to see whether or not this is Earth-directed, but I'm betting it is, and that means we could get a bumpy ride easily from the 24th all the way through the 26th before things calm down. Now, switching to our moon, we are passing through the new moon phase on our way through the first quarter, and by the Halloween date, we will have about a 68% illuminated moon. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe the peak of the Orionids, well, you're going to have this bright companion, so you're going to need to check your local rise and set times. And now, switching to our solar storm conditions and aurora possibilities over the coming week, we are expecting this kind of bumpy ride from those mini little solar storms that are headed towards Earth. The first should be hitting us right around the 24th, be just a bit of a graze. I'm expecting maybe active conditions at high latitudes with up to about a 20% chance of a minor storm. And this could carry into the 25th and possibly into the 26th, where we might get hit by a slightly larger storm. We'll have to see how that unfolds. So I'm going to just hold off to say that it's going to be bigger or not. But just be aware that we could get a bit more of a bump up because of that. And then aurora photographers, if you're at mid-latitudes, well, I'm only expecting unsettled conditions, but we do have about a 25% chance of active conditions, possibly about a 10% chance of minor storm conditions. And that's going to be, again, over the 24th, 25th, and possibly 26th before things calm down. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are sitting in the mid 130s to 140s, and I'm expecting that solar flux to climb here over this week because we've got some big regions rotating into Earth view. NOAA's got us at minor noise on the dayside radio bands, sitting at about a 15% chance of radio blackouts at the R1 to R2 level. That's likely going to climb to probably about 25% as we move into the early part of next week, and possibly even higher. We don't really have much of a chance of X-class flares right now at the moment, but that again could change as we move through the latter part of the weekend into next week because of those new regions that are going to be rotating into Earth view. So overall, it is a bit of a reprieve from the loud noise that we got on the dayside radio bands last week from those regions that have now headed far side, but we're watching them because they will be rotating back into Earth view in about 10 days. And now switching to our radiation storm and polar aviation outlook over the coming week, we are sitting at the D2 minor range. This is at flight level 360 for you aviators. It's also the S0 quiet range for everyone else. It doesn't mean that we're completely quiet. We are sitting at elevated conditions right now. Not expecting that we're going to get back up to an S1 level, but this is because of that big far side blast. So if region 4246 plans to let off another one, well, we could continue to see elevated, possibly S1 level conditions, but it's a low risk. Likely by about the 25th, we're going to be back to almost normal, and then through the weekend, things should be quieted back down. So if you're a frequent flyer, and this does include air crew and you high-risk passengers, please pay attention. We do have slightly elevated conditions, and please include this in your flight plans. So the space weather this week has gotten pretty exciting. We don't have a lot headed toward Earth. In fact, we just have a couple wispy solar storms that will give us a bit of a bumpy ride starting about the 24th and possibly in through the 26th and maybe even the 27th before things calm down. It's a little early to tell, but aurora photographers, if you're at high latitudes, you could definitely get a bit of a show. Aurora photographers at mid-latitudes, well, likely the solar wind speed is going to be too slow to bring some decent storming down to mid-latitudes. So only if you're dedicated and you can chase substorms should you bother to try. Now, amateur radio operators and emergency responders, well, things are looking pretty good for you right now. We're getting a bit of a reprieve. All that noise on the dayside bands you've probably noticed has dropped a bit, and that's going to continue easily through, I'm hoping, about the weekend before you start noticing the noise rise again. So enjoy. And now you GPS users, well, things aren't too bad. Day side, we don't have a big risk for radio blackouts. And on the night side, we're only expecting mild storms. So things should be pretty good for you all the way around the world, as long as you stay vigilant near dawn and near dusk. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay, thank you, Tamitha, for a fairly concise, quick report there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, I've got my levels from live to record there is not quite right for some reason. 4, 1, 2, 3, 4. I think that's okay though. All right, getting into spaceweather.com. That's our current disk of the sun, with a bunch of sunspots that you can see there. And currently the solar wind is averaging 500 kilometers a second at a density of 2.19 protons per cubic centimeter. The current sunspot number is 92, and the auroral glow over the Antarctica South Pole is looking like this at the moment. Not very much to write home about. Quite vague, really. The coronal disk image of the sun looks like this. And where else are we? The radio flux is currently, if I can find it, somewhere in there. There it is, 130, measured at a wavelength of 10.7 centimeters, so 130 solar flux units. And the KP index is, the planetary K index is currently 2.33, which is considered quiet. And over the next 24-hour max is going to go to about 3, KP3, which is also considered quiet. What else do we have in there? They're saying here that, as Tamitha was saying, possible Earth-directed CME, a CME that left the sun during the late hours of October 23rd, might reach Earth this weekend. NASA models suggest a direct hit on October 26, bringing a chance of G1 class geomagnetic storms. This is a low confidence forecast. Several overlapping CMEs left the sun on the 23rd, and they were tricky to untangle. So there you go on that one. I think that's all I've got there. It's worthwhile mentioning. Same old for asteroids, near-Earth asteroids, potentially hazardous asteroids, PHAs, which are space rocks larger than 100 meters, and that can come closer to Earth than 0.05 AU. Because none of the PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. As of October 24, there were 2,349 potentially hazardous asteroids, and there's a big list of them there. Okay, that's spaceweather.com, and I think that basically concludes tonight's broadcast, just as we go to after 11 o'clock, so we'll leave it at that. Thank you very much for people that have tuned in to listen as usual. To Andrew and John that have sent me emails and reports. I can see on Discord we have again Andrew and Steve, VK3SPX, and Dave, VK3KDM, resident Mount Burnett Observatory astronomer. Thanks guys for watching Discord, and apologies for getting not getting Discord up and running at the start there. Completely forgot to get that going actually. I think YouTube's been working okay. So that's about it. We shall now go across to 35
2541 kilohertz to see if anyone wants to do a quick check-in as I try and get a new page here on the logbook. And we'll see how we go. Alright, hang on. Right, now I'm going to remove my headphones because nobody is going to hear anything anywhere else if I have my headphones on, so I shall just remove that. In fact, I better make sure that the speaker is off because I'm going to get instant feedback. Alright. Oh, freedom. Alright, so this is VK3 EKH listening on 3541.
VK3 SBX.
Gee, the band sounds a bit noisy tonight. That could be a problem. VK3 SBX, any other stations? Yeah, the band's quite noisy. It's, yeah, okay, alright, fair enough. I'm going to have to, I'm going to have to think about bringing in my linear amplifier. I used to run the linear on Friday nights. I used to run that a good 400 watts. It always helped, but I don't think the only reason why I run low power now, 100 watts that is to make sure that the modem doesn't fall over. Anyway, we shall see about that for next week. Alright, well, the only station checked in is Steve, so across to you there, Steve, VK3 SBX, VK3 EKH.
VK3 EKH is VK3. G'day, Clint. Only station, that's amazing. Yeah. I wonder where everybody is. Actually, I was very late to the broadcast, I'm afraid, Clint. My phone just came up here in Barringup, so we were constantly sort of moving beds around and stuff like that. So I only caught you from really the dish onwards. That was interesting. Maybe someone doesn't actually know that with some Australian involvement in the Apollo program. But I guess it's a while ago now, isn't it? I remember I was at high school at the time. I remember they cancelled the lessons and sent us all home to watch the moon landing on our 21-inch black and white TV. Yeah, I'll never forget that. Yeah, I had a play with a Flex radio today too. I think a 400 watt Flex radio remotely. Couldn't quite get the microphone levels right, so I wasn't really getting enough of a signal out. But Bendigo Club is installing one at a place called Bridgewood in northern Victoria on the top of 45-metre tower with a rotatable tree or foil with Yagi on the top. So it's going to be fun to play when it gets up and running. Probably, of course, we do have our two interests here. Anyway, yeah, so I'm sorry, I don't have a lot of witty commentary about the broadcast on account of my lateness there, but it was interesting to see the pictures of the dish and what have you, and they always go with that cricket thing, you know, as if you'd play cricket on an instrument like that. You know, I just imagine what the scientists would have said if you'd gone up there and played cricket on there, on this dish. That would have been really amusing. Anyway, thanks, Clint. Maybe someone else will come back here, I don't know. And you better tell us how you go with your setup as well. VK3 EKH, VK3 SBX.
Yeah, no worries, Steve. VK3 SBX, VK3 EKH. Yeah, that's right. EKH returning. Yeah, my audio levels are all over the place here.